Hello, everyone. I'm Jeff Young, Head of Business Development at Stratus Technologies, and today I'll be your host. I'm really excited because we have an excellent cast with us today. Our first speaker is Craig Resnick, Vice President of Consulting at ARC Advisory Group. And Craig will walk us through market trends accelerating digital transformation and edge. Next, we have Dr. Peter Photos, who is the Chief Technology Officer of Streamline Innovations, and he will share his perspectives on intelligence in the field with edge devices. And last but definitely not least, we have Jessica Spurlock, Process Automation Engineer from Rubberlite, who will provide insight into her gains in production and quality utilizing edge computing concepts. Before I hand the reins over to Craig, I'm going to walk everyone through the who, what, and where of edge computing and how to start rationalizing cost and payback. Also, I would like to remind everyone that if you have questions throughout the webinar, please submit them in the Q&A feature, and we will address them as time allows. The concept of digital transformation has often been a daunting and overwhelming topic, but in the past 3 years, it has started to come into focus. Clarity is being achieved when organizations truly focus on outcomes. Teams are making educated bets on where to begin to deploy new technology and processes that will make an immediate impact. The exciting dynamic about edge computing is it takes teams right to where the action is happening, right to the origin of the data, because that's what the edge computing is all about. It's literally tapping into the digital gold we're all mining today to help build new data sets so we can make more educated and informed decisions. Just for a moment, let's look at where this is happening. Edge computing is happening everywhere throughout the industrial ecosystem in both discrete and continuous process applications. The companies listed here have found ways to leverage edge computing, either on machines where you would have applications like a SCADA, HMI, thin client configuration, on machine analytics, or even asset performance. Also on production lines where you would run applications that measure KPIs or metrics, or even at remote plants where you would be focused on plant-wide interoperability and overall equipment efficiency. What do all these organizations have in common? They are leveraging an edge computing architecture that puts the power in the hands of the people that are focused on production. And it is production-centric outcomes that are creating the payback for their digital transformation initiatives. So, how's this done, and what should you consider? To start, you should consider modernizing with remote-first operations in mind. As we've all experienced firsthand over the last 12 months, the legacy concepts of a support-intensive PC and centralized server architecture can be very detrimental to operations. With a proper edge computing implementation, organizations can leverage a remote-first ideology that enables a support team to assist remotely, saving costly travel and logistics expenditures while also maintaining a safe work environment and eliminating unscheduled downtime. So what are some of the benefits of edge computing? We have developed research that shows organizations can decrease technology cost while improving IT and OT productivity utilizing edge computing concepts. Some of the benefits include performance and reliability gains, increased uptime, and cost reductions in application licensing. Finally, a couple thoughts on planning edge computing projects or initiatives. As these are developed, you should consider, are you achieving returns that align with the figures presented here? This type of average ROI, or payback in less than 8 months, and average annual benefits of greater than $50,000. I hope this provides insight and clarity into rationalizing the cost and payback and criticality of edge computing. Up next, I would like to introduce our first speaker, Craig Resnick, who will touch on market trends, accelerating digital transformation and edge. Craig?
Hey, thanks a lot, Jeff, and Craig Resnick. Great to be with you here today. And I'm going to talk a little bit about the whole marketing trends and how it's all being accelerated as part of the whole digital transformation process. And, we start off with a very bold statement, which is, without without edge and digital transformation, you won't have the flexibility and agility to maintain the competitive advantage in the new normal. And it's pretty strong. But to be very honest with you, once the pandemic hit and we were forced into this situation of remote working, social spacing, problems with visibility and the flexibility of a supply chain, it really accelerated the whole demand for what you need in edge computing, because people are so worried about how am I going to continue to operate my plant, how am I going to maintain my a very common term since the pandemic is operational resilience. Am I going to be able to survive not only this pandemic, but am I now have an infrastructure in place that I could survive another catastrophe at some point in the future? Again, am I able to fulfill the requirements of my products, my shipping my products, fulfill the orders, especially if I'm in a product category that's really in very, very high demand as a result of the pandemic? Am my personnel protected? And at the same time, do I have the right security? Do I have the right cybersecurity techniques to be able to protect now with certainly the fact that I'm now allowing all this remote access that I did not have in the past? So we look at how an edge platform can help in that area. I mean, these are things that are certainly, and especially those that are designed for automation, designed for people with an OT background, because now they can be deployed relatively easily. And it really changes the way that work processes are handled, how information is gathered, how it's stored, how it's executed, because it's at the device level. It still maintains its real-time status, shall we say, and it gives people that extra visibility that it takes, especially if you're not in front of the machine, whether you're in a remote knowledge center or you're working from home. But to be honest with you, there's really no way today that you can be completely effective if you really don't have this. Certainly an edge strategy as part of your digital transformation process, especially with this new normal.
Hey, Craig, this
Now,
is Jeff. I have a
sometimes
quick question for you. So,
Sure.
at a high level, as we're looking at this, how do you feel leaders are prioritizing digital transformation initiatives right now? As we move into 2021, do you think they're approaching this from a more risk-oriented or reward-oriented position?
I would say this: our dividing line is March 2020. Before March 2020, people would look at this as something that was a nice to have. Maybe we'll put that in our 3 to 5 year plan. But we're still right now going through the calculations whether or not this edge and digital transformation strategy, what's the payback, for example? And once we get a better handle on that, we'll decide how soon we want to execute. Post March 2020, all of a sudden, ROI remains critically important. But then once, as I was saying earlier, the whole term operational resilience came into play. And that completely accelerated people's digital transformation programs that would bring edge devices kind of to the forefront, because they needed to be able to execute the ability to work remotely and do it in a safe and secure fashion, and have that information at the device level that could be transmitted to the person wherever they may be, and at the same time be processing that information in real time, and having a hybrid strategy working with the cloud, so they can share that strategy with not only the business systems and the enterprise systems, but also to send it back into the supply chain so it can work with the raw material suppliers, and if they need to be able to make some quick changes in their raw material procurement, that they can as a result of constant changes in what factories may be closed, may be open, or having a supply chain problem themselves. So I would say that's when things really changed, and it went from more of a it kind of went from a strategy to a tactic, shall we say, to really make sure and really.
That's great insight. That's great insight. Thank you, Craig.
Okay. So if we look at where we find edge devices, I mean, it's not just limited to any particular industry. I mean, whether it be throughout the process industries, discrete industries, transportation, agriculture, we certainly find it everywhere. But But ultimately, it's collecting data, analyzing data, and storing data. But the unique part of the edge is that it's doing it at the device level, at the machine level, and on site. And so that way you can take advantage of whether it's in remote locations. And one of the things that's really critical with it's an edge automation platform is the fact that you don't have to be a Python programmer or an R programmer. If you're somebody that comes through the OT side and is comfortable, doing 61131 programming for PLCs and PACs, or programming DCS systems, maintaining drives, you don't have to have the heavy programming skills from an IT side to be able to deploy these platforms. So they're designed with cybersecurity in mind, so they recognize the fact that access, you have to certainly have the appropriate firewalls in place. And because of that, it's really become one of the fastest growing areas in automation. I mean, ARC writes quite a few market studies, and the whole edge automation platforms are definitely have very high growth rates, and their growth rate was actually accelerated as a result, certainly, of the pandemic in 2020. So if we look at kind of like this whole architecture, and we see, we're looking at IT, certainly as a representation of applications in the cloud, and then certainly OT as far as the devices down at the site level, and then we look at some of the gateway devices that allow IT and OT to connect. But what this does is that this just shows that that part of having an effective edge and digital transformation strategy has to incorporate the whole area of IT-OT convergence. I mean, if you really did not have this process going on, you probably couldn't fully take advantage of having the edge strategy, because you wouldn't have that ability to get that information up into the cloud, because even though the information is processed in real time to avoid any sort of latency, but again, that information, to really close the loop, shall we say, has to get up into the business systems. And that's the reason why cloud and all the applications of the cloud are really so important. And so you really have to make sure that you have that whole IT-OT convergence. At ARC, companies that have really accelerated their process greatly with IT-OT convergence, it's almost getting to the point we sometimes call it IT-OT fusion, because we could see a period of time, 5 years from now, when we may not even see a difference in certain facilities between their IT groups and their OT groups, that they may begin to really, fuse into one. The other thing that's interesting, if you notice from the chart, is that edge devices are not just on fixed assets. They're also part of, mobile assets. So it's on, whether it be moving trucks, whether it be, walking people, maintenance people that are certainly walking the plant. You're really trying to combine everything that's fixed, everything that's mobile, but the idea is that everything is universally connected. And when those devices and assets that are connected actually have the intelligence that it takes to collect, analyze, store, and share the information in real time, where it's needed and when it's needed. And it's something that's not just for the control systems, but it's also done for certainly power monitoring. It can be done on for OEM machines that are being shipped to locations all over the world, so those machines can be properly monitored. So there's no limit as far as where those edge devices can be mounted and where the benefits can be derived, from those edge devices. So sometimes people will say, when we present edge within many of our end user and OEM clients, and we'll say, well, what's in it for me? Here I am. I've been working for a long time in this industry. Tell me why I need to learn about the edge, both from a professional side and also personally. And it really is part of a whole new way of doing business and operating. It's really a whole different way of leveraging all the kind of different types of services that are going to be available. And so now no longer are you always just kind of collecting money from your customers on the CapEx side of the budget, but now you're able to sell some services and recurring revenue that will allow you to get on the OpEx side of the budget. And it also helps as companies are beginning to start to sell what we call as outcomes instead of products. So instead of just selling you product A, we're selling you a result. So your customers certainly can improve their own business model. So it makes the relationship very, very dynamic. And it's really important professionally that people really understand where some of these changes and nuances are in the marketplace. And what it also does is it really helps you as far as, growing your own professional skill set and your own career. You're now learning how these whole new ecosystems are being established. You're going to be dealing with maybe a different set of suppliers. You're going to have to be using a lot of disruptive technologies that you may not have been familiar with in the past. And so it's really a new way of supporting your customers and providing new sources of revenue for your own company. And at the same time, it also is going to help you manage, whenever there's change, there's always a certain amount of turmoil in any organization. But it really helps you kind of adapt and help your organization adapt to that change. So what might feel like one step back is really many steps forward as you go forward with your Edge and digital transformation plan. So really, if you haven't started thinking about it in the past, you really need to be thinking about it now. And because I can tell you, if you're not, your competitors are absolutely have Edge and digital transformation plans. And at the same time, you want to make sure that your whole IT/OT convergence plan is moving forward within your organization. That journey is certainly in the midst of progress, and that journey should also be accelerated where possible. And knowing the fact that your ultimate goal is to truly have that IT/OT fusion in the future, when one day if we were doing this presentation, people won't see a distinction between IT and OT some years from now. But it's really key to do that and maintain the continuous availability that's certainly required from any sort of manufacturing and industrial automation. So again, I can't emphasize it enough. Edge and digital transformation, continue to move forward, make progress, but it's not an option. It really is mandatory going forward. So with that, I want to thank you very much, and want to introduce Peter. Going to take it away.
Thanks a lot, Craig. So I'm going to talk a little bit about what we have done here at Streamline. And there we go. And a little bit about what Craig just spoke about, how we can take an OT, an IT project that we've developed for ourselves and turn it into something that actually potentially has commercial value. And I'll talk about that at the very end, about where we're going with that. A little introduction to my company, Streamline Innovations. Our mission is to eliminate pollution through technology. So we actually design, build, operate, and integrate our own units. We call them Valkyrie units, and they remove H2S from natural gas. We also do purification of CO2 streams. We remove ammonia, carbon dioxide, H2S. We are in that space. And really, we've found that a lot of our work is providing technology through existing systems. So we're doing work on existing builds as well as new builds for ourselves. So this is one of our units. This is the Valkyrie unit, the Valkyrie process. I don't want to get into too much chemistry and too much talk about our chemistry, but I am going to give a little quick lesson about this. This unit removes hydrogen sulfide from natural gas. Hydrogen sulfide is an extraordinarily toxic chemical that is found in 40 to 50% of all wells in the world. The United States is no exception. Obviously, when you turn your stove on, you do not want H2, this toxic chemical, coming into your home. So we need to remove it. There's a bunch of technologies out there, and ours is really kind of a unique process that we have brought out of the old days. It's an old process that we've really brought into a new technology, really through operational technology, and that's what I'll explain. You don't need to know a lot of process or chemistry, but I'm going to put a picture up. This is the diagram of how the unit operates, but there's two important points. The first is when the gas mixes with our liquid, our Talon chemistry, there's a chemical reaction that occurs. And when that chemical reaction occurs, the H2S is destroyed. If the reaction does not go far enough, we'll give off more, it will give off H2S, which is not good. If the reaction goes too far, we'll destroy our chemistry. And as you'll see, we can't reuse it. And so the second thing to look at is over here in our regeneration reaction. We mix our chemistry with air, and we can reuse that chemistry over and over and over again. So it really is clean tech. It really is our clean tech product. But there's a condition. If you don't put enough oxygen into the system, you don't regenerate enough chemistry, and you'll slip H2S. If you over-oxidize the system, you'll burn the chemistry, and you won't be able to regenerate it. So the short story is we are running this reaction as a clean tech, removing hydrogen sulfide from natural gas in this place, and we have to control 2 chemical reactions within a very exquisitely narrow band. That's a challenge, because if you think about it, that's not really done except in refineries. But it's more than that. We're mixing, we have the gas flow rate changing from minute to minute, the H2S concentration changing from day to day. So we have variable inputs, and we have to maintain these chemical reactions. We also have pumps, filters, lines, valves, all these things that are typical process, industrial process equipment that we have to keep running. And then we have solids and gases and liquids, because we produce elemental sulfur, which is a fertilizer. So we effectively convert this toxin to a fertilizer. We have solids, liquids, and gas circulating through our system, which requires a tremendous amount of maintenance and maintaining levels and maintaining flow rates. They can't be too high, they can't be too low. There's a lot of control going on here. So not only do we have a chemical process that we're controlling, we also have a standard plant that we're controlling that is also more difficult because of the presence of multi-phases. Now, to add to the story, these units are typically in remote locations, an hour or 2 drive from the nearest human, really only accessible during the daytime, and our clients require a 95+% uptime, and our entire OT budget is $50,000. Go do it. It's a very difficult challenge, and it's extraordinarily challenging, which is why this technology was not truly commercializable until this decade, until Streamline has really taken over and really brought in some impressive operational technology tools to help us control this unit and do this task. So this is our Super Valkyrie project. This was a project in Pecos, Texas, for a client. We're treating about 60 million cubic feet of gas. It's 3 amine plants and 3 Valkyrie plants. Now, typically when you build these sorts of plants, the rule of thumb is that you need about a half of FTE per unit. So you've got 6 units, you're talking 3 operators, and then daytime, nighttime shift, 6 heads, 6 FTEs. It's a labor intensive to operate these units. Plus, maintenance requires call outs out to the site. Support team needs to go out to the site to control it. And the mission for this project was to do this with only 3 FTEs. So keep maintenance to a minimum and keep support off site. I'll show you how we did. So we chose the Stratus ZTC Edge. So we chose this for a couple of reasons. Number one, because of the redundant processing, the dual processing in the system is extremely robust. And because we can lose power on one side or something can go wrong on one side, the other side takes over, we get this beautiful uptime that's really great. And we're able to put the database on the second virtual machine. And so that allows us the flexibility of being able to replicate this unit. So we can make 6 of them, we can make 3 of them quite easily. The computing power is chunky, it's robust, it's got plenty of CPU, and the cost is modest, and it fits in our budget. And so on this machine, this dual machine, we're running Ignition as our communications to our OPC, to our PLC. We're running a PostgreSQL database. We're running Python scripts that do advanced modeling and AI and machine learning. Time calculations of over 20 KPIs. We have our Ignition gateway. We're doing APIs. We're pulling in weather from the National Weather Service to the site and using that calculation and things like heater calculations and temperature calculations. And then we're also launching a Wi-Fi signal from the box, from the system itself, so that our operators, rather than having to plug into the system or going up to the HMI and touching the screen, they could just open their laptop in their truck and actually communicate with the system. So this is how we made our unit smart, and we did it with a very reasonable budget, right? So we have the unit going to a PLC, which is doing minute-to-minute calculations. We have the Stratus that's doing hour and daily calculations on the fly, running Python, storing the data, running ignition, conferring with the Wi-Fi. It's doing a lot of pieces, and it needs that robust uptime. And then that data gets sent to an Azure database out in the cloud, where we do day-to-day and week-to-week and month-to-month calculations using artificial intelligence calculations like Seek, using a software called Seek, to do some much more sophisticated modeling. So our intelligence is tiered across multi-layers: the PLC, the Stratus, and then the cloud database. That's all doing its role. And we have a good bandwidth between the PLC and the Stratus, but we don't have a great bandwidth between the Stratus and the Azure database. So we have to make sure that the data that gets transmitted there is less data, but it's more heavy calculations. The Stratus is a little bit lighter than, obviously, Watson, and so we have to be able to do, or machine learning that Azure offers. So we need to be able to do less calculations there, but we have much more data to us. So by tiering our intelligence and making a tiered intelligence, we have a very tight OT structure that gives us intelligence across the entire system. To make it even more interesting is that this particular project has 3 units that are spread out about 8 miles apart. And so there's also, the client had a Tropos network. And so the Stratus allowed us to connect to this Tropos network. And so what we've been able to do is create a remote control system, a remote control room. So inside the truck of the operators, there is a Tropos connection that allows them to see all 3 HMIs simultaneously in their truck. When they step up to a site, they can connect to the Wi-Fi, or they could step up to the device itself, or they can hardwire in. And then inside their sleeping quarters on the facility, they're able to see all 3 sites. And so what we've been able to do is essentially create a connection here, a system here where there's remote connectivity, but there's no cell signal. The cell signal in this area is absolutely terrible. There is no cell phone. And so we've been able to replicate remote connectivity through the Tropos network, which is not an easy thing to do because of the idiosyncrasies of Tropos. But what's further is, with ignition running on the Stratus, we're able to do a lot of things that you really can't do elsewhere. What we've done is our system has ignition serving the HMI from the Stratus system locally. Our control room operators in San Antonio are able to connect via cellular modem with a booster signal, the signal's pretty weak, to that network, and they are able to connect to ignition directly. So what the control room sees, what the operator sees in their truck, and what you see locally are all the same thing. And so our control room has exquisite control over the entire unit, and that gives us a tremendous value. But also, because they're connecting to the network, they can log into the Stratus OS system, which is their base operating system underneath the virtual machines, and go in and restart virtual machines. So when the database is acting funky, they can restart the machine without having to send a human in there to restart the computer. They're able to see the machine diagnostics right from the web interface from San Antonio. And that gives us their ability to diagnose problems. Why is the computer running slow? Or why is there a memory leak? We can identify those issues immediately. And so one of the things we've gone even the next step is to integrate ignition into the Stratus, or the Stratus into ignition. And so now we have on the screen itself, we can restart the Stratus from ignition, which sounds crazy because the ignition runs on the Stratus, but also we're getting to the point where we're able to restart individual virtual machines from within ignition, as well as being able to pull in those diagnostics so we can use that data to identify causes of downtime. So really, we're integrating Stratus right into the HMI, which is a very unique and powerful capability. So here's the results. We are able to essentially build a smart amine plan that is managed by AI 24/7, and a control room that can see this unit 24/7 as well. So we have total connectivity against this unit at all times. During the daytime, the operators are there. We have 2 FTEs. We said we were going to do it in 3. We predicted 6. We did it in 2. That's a 66% reduction in labor costs from our estimates. The call outs are coming from the control room, not from the field. That means that we can be a bit more proactive about our calls. We've instituted machine learning that can do predictive maintenance. And so the computer actually can call out call outs long before the pump actually breaks. And that's been a tremendous value for us. And it's all done through the control room. So Zendesk is integrated into Ignition. So when things stop working, it automatically creates a Zendesk ticket. When it thinks it's going to stop working, it automatically creates a Zendesk ticket. So we've integrated all of these pieces together across the entire spectrum. It's a combination of IT and OT. And then on top of that, we've reached a 99.5% uptime, which is absolutely fantastic. We've blown it out of the water. So where are we going? Yes?
Yeah, I got a quick question for you, man. That's a great breakdown. And I love the way you explained how, you're working on a tight budget, right? So this is an economical approach to it, but the way you described it, it seems, very complex. For some of our audience who are considering integrating similar technologies into their own solutions, what would be some recommendations that you would make to them to keep in mind?
So there's a couple of important things. Number one, you have to make sure that you have the computing power to be able to do what you need to do, but you don't also just go too lean. We initially went too lean on our computing power, and we ran into a lot of trouble. The second thing is don't be afraid to segregate roles. So, for example, we use a external modem. We used to use an internal modem, cellular modem within the device, and we found that we got a lot more robustness when we bifurcated the computer and the modem itself, for example. The Wi-Fi system is separate from the computer box, and that gives us a little bit more flexibility so that when the Wi-Fi goes down, that doesn't mean the computer is going to crash, or if the modem isn't working, the computer is going to crash. So there is advantage of splitting your equipment and rather than a single fit-for-purpose device. And then the final thing is also keep in mind that with modern SCADA systems and things like Ignition, there's no end to what you can incorporate into the HMI. And so you could start bringing all of this information into the HMI, and it's not hard. There are modules out there, and there are companies out there that build these modules to help you integrate those devices into the equipment. That's a great question. So to kind of sum up where we're going and where the future of IT and OT is, it's really go edge or die. I took this from the New Hampshire license plate. And it's really because if you look at, and I'm going to give an oil and a gas example. If we look at the entire oil and gas pathway from the wellhead to sales, there's a variety of pieces of equipment along the way. And we have shown with what we've done already, we've made our Valkyrie smart, we've made our aiming plant smart. But there's no reason why we can't take the same methodology, that box running a Stratus with a modem, with no PLC. I'm just talking about from the Stratus to the cloud. A Stratus, a modem, a Wi-Fi setup, all of these pieces that we can't add that to all of these other systems across the board. So I'm talking about smart wellheads, smart glycol units, smart JT skids. And some of these are names you aren't familiar with, but you could take any plant you have and you could start building boxes that contain all of the OT you need to make it smart. You don't necessarily control the unit, but you're starting to build data. Like I said, 20 KPIs is not a big deal for a computer. And so we've launched what we call the Valkyrie Intelligence Platform, which is a standalone box that can be integrated into an existing unit. It plugs into any one of these types of devices. We're developing them for about 4 of these right now. But we could develop it anyone could develop this for any process. It's powered by Stratus. Seek is running in the background doing artificial intelligence and complex calculations like predictive maintenance. It becomes a turnkey package, which makes it so simple because really anybody can build these things, but nobody has the time or resources to do it. And then finally, the remote monitoring piece and it becomes something modular. So it's not necessarily a product that anyone can build this for themselves, right? This is really about taking the technology that's available off the shelf and putting it into boxes and making it modular. And this is exactly what Craig had mentioned about it turns into a service industry rather than a operational technology project. And with that, I thank you for your time, and I turn it back over to you, Jeff.
Great, thank you, Pete. Up next, we have Jessica Spurlock. Jessica, are you ready?
I am ready.
All right. Sounds good. The floor is yours. Thank you.
All right. Thank you so much for inviting me to tell our story today. So Rubberlite, a privately held company, has been operating in Huntington, West Virginia for 35 years.
What?
Hunting
I was only supposed to take. Can you hear me?
is located on the banks of the Ohio River and is centrally located between the Mid-Atlantic and Midwest and Southeast regions of the United States. And Huntington is also home to Marshall University. Our campus extends over a city block with 300,000 square feet under roof. And Rubberlite employs 146 people with an average tenure of nearly 15 years. And though we're lean, we supply over 1,600 customers around the world, and our foam is used in a wide variety of applications in practically every vertical market. And Rubberlite's business model revolves around two key operation centers. First, we skive our bun stock cellular rubber products to a certain thickness, and we're the largest, one of the largest in the United States at doing this. We're the recognized leader of converted cellular rubber bun stock, attaining the tightest tolerances in the business. And we've been doing this since opening our doors in 1986. And in 1997, we started manufacturing our own foams to replace some of the products that we were converted with other suppliers. And since then, we've become a leading manufacturer of custom engineered, medium density, free rise polyurethane foams. And this operation center accounts for approximately 50% of Rubberlite's revenue stream. And in the early 2000s, Rubberlite began offering flexible composite systems and textile coatings as a value add to product from either operation center. Now, the polyurethanes manufacturing department was chosen as the beta site for implementation, becoming the blueprint for the rest of the organization with regards to automated process controls, data integration, and just a higher level of sophistication and operating discipline. So this area, we chose it because it had the processes and the technology in place, and the potential benefits from a successful implementation would provide the most value to the organization. Now, in my previous jobs as an engineering contractor, I had the opportunity to develop projects for many organizations of various size, diverse industries, and different levels of operating sophistication. And each company faced common challenges as they embarked on their digital transformation journey, and Rubberlite is no exception. There was no integration between standalone systems on the plant floor. I refer to them as islands of information. We had very limited information on our process. Often we didn't realize the effect on product quality until it was too late. The polyurethanes department was controlled from a single Windows XP computer running on the plant floor in the middle of the production environment. If this single computer went down, the entire manufacturing line was in trouble. Production data was stored in binders of run sheets for nearly 20 years, where the operators would write actuals next to targets whenever they could make it while they're making product. So this provided a disjointed snapshot into the material's properties. Now, our standalone InTouch application provided for continuous data collection. However, this single XP computer's hard drive is only 15 gigabytes. And as we integrated more systems, our ability to log longer durations of data became increasingly limited. Eventually, data was only logged during production runs. No data was provided during idle times, so there was a large gap in our troubleshooting abilities. Exporting the data from the primitive historical logger was cumbersome, and it took us nearly an hour to generate a report. So therefore, it was often a last resort instead of our first line of defense. Now, as I mentioned before, the average tenure of a Rubberlite employee is nearly 15 years. And in the manufacturing of polyurethanes department, it's actually closer to 20 years. And with that comes a lot of head knowledge with limited standardization across the plant. And therefore, product quality was variable because tasks were not performed in the same manner. And due to surprise events and undefined process capabilities, the execution style of Rubberlite was largely reactive in nature. And despite these challenges, Rubberlite had been very successful in development of specialty products and niche markets. However, this kind of success can lead to the natural evolution of a culture that can be more resistant to change due to the commercial effectiveness of the status quo. There's often risk in changing, and the if it ain't broke, don't fix it mentality, it can be prevalent in existing work practices. Completely understandable, this mentality can impede continuous improvement initiatives. Now, this project was a prominent step forward in Rubberlite's commitment to growth and innovation. Now, working with our distributors, we determined the architecture necessary to accomplish our goals, utilizing Aviva system platform and other products from Aviva. We required 8 different servers to run the software packages, and it was determined that virtualization was the optimal approach. However, what about redundancy? In a traditional environment, we just double the requirements, but that also meant double the labor costs when configuring and maintaining the VMs, double licensing costs of operating systems, software applications, and double the hardware costs of additional servers, storage, networking, and power. Ultimately, we decided to configure all the virtual machines and require redundancy on our Stratus server running on the edge. And the following are reasons for this decision. Stratus provided Rubberlite with a turnkey solution that combined hardware, software, and continuous monitoring services. Replicated fault-tolerant components process the same instructions at the same time, called lockstep. In the event of a malfunction, the redundant component acts as an active spare that continues without system downtime or data loss. Stratus provides totally redundant servers to prevent single points of failure. And this server also has technology to prevent application downtime rather than just recovering from it. And even though it's 2 physical servers operating in lockstep, they appear as one server on the network. And this eliminates the need to purchase multiple hardware, software, and licenses. And it reduces the system admin costs as there's only one server to maintain and configure. Now, with regard to Stratus and its functionality, there has not been a single downtime event since its installation in March of 2016. Now, unfortunately, the only time that it was down was related to power outage one Labor Day weekend. And before I was notified from anyone at the plant, I had 2 emails waiting for me from Stratus saying that there was an outage, one from the automated phone home system and one from their dispatcher. Now, one of our key performance indicators is production of non-sellable material. This project was implemented in March of 2016, and as you can see from the graph, this KPI was improved by 46% within that first 9 months of use. Real-time data availability has guided the direction of process improvements that have helped this number to come down even further. And since implementation, Rubberlite has realized an overall 80% reduction in off-grade material. And that's amazing considering that Rubberlite has added several new materials to the portfolio, including 2 new product lines. And since implementation, we've increased our overall production by over 20%. The implementation of a fully integrated DCS and the data historian with a fault-tolerant server backbone has facilitated this growth. And our partnership with Stratus has helped Rubberlite evolve into where we are now, and it's put us in the position of where we can continue to grow and improve. So thank you for your time.
Thank you, Jessica. I do have a quick question for you, and it'll be a similar question to the one that I posed for Pete. So for some of our audience members that are considering integrating similar technologies into their own solutions, what would be some recommendations that you would think that they need to consider before they do that?
So I would recommend starting with an area of the organization that is the most ready for it and use it as a blueprint, much like we did with the polyurethanes area. It's less of a shock to the organization if you choose the area where the processes and the technology are already in place. That way you can have the most potential benefits from a successful implementation, and that way it provides the most value. And whatever platform is decided, my recommendation would be to future-proof the design as much as you can within reason.
That's fantastic. Thank you very much, Jessica.
You're welcome.
Again,
thank you.
Yeah, thank you. Again, I would like to thank our speakers for their insights today. I believe they have provided excellent commentary that helps us all understand the rationalization of cost, payback, and criticality of edge computing for Industry 4.0 automation initiatives. Also, I would like to recommend, or I'm sorry, I'd like to remind everyone to visit the Stratus virtual booth, where you can see the latest content on edge computing, as well as have the opportunity to speak with one of our edge computing experts. Okay, that's a wrap for the presentation portion of our webinar. So now we will take some questions from our audience.
Okay, everyone. First up, this is for Mr. Peter Photos. Peter, and this is, I don't know if you noticed, but a portion of your presentation there, we had the audio cut out. And I believe you were talking about the architecture of the Stratus. So if you don't mind, could you fill our audience in, repeat again what you're covering on the architecture to make sure that we don't have any gaps?
Sure. So we used 2 virtual machines on the Stratus box. The first machine ran ignition, and the nice thing about that was that all of the ignition software was basically boilerplate for all of our units. So we just had to build one ignition virtual machine that we can copy over all the units. And then the second virtual machine was the PostgreSQL database, which varied from unit to unit because every unit generated its own data. So it allowed us to have multiple distributions of the same setup at multiple locations quite easily.
Oh, okay, great, great. Thank you. And then I have a follow-up question for you as well on that too, since we already have you off of mute here.
Sure.
One thing that you touched on too was you spoke about the integration of the Stratus ZTC Edge on-prem and an integration into Microsoft Azure Cloud. So when you combine the two, the on-prem and the cloud piece of the architecture, how has that impacted, the organization as a whole for Streamline?
It's been great because number one, at the local level, we have nice calculations, like I said, about 20 some odd KPIs that are being calculated in real time locally. But then that gets transmitted to the Azure database. And then from that interface, we can look at all of our units, all 19 of our units, as a holistic approach. So now when I get my daily report from the operations team, I get a single document with all 19 times 20 KPIs, which is 400 KPIs, I could see in a single document. So what's managed in the cloud is kind of a holistic approach across the fleet, and what's managed locally is managed at the site level.
Oh, that's fantastic. Thank you so much, Pete.
Sure.
All right.
I see 2 questions up here.
Yeah.
One, we can restart the PLC using a Guard Logix machine from the HMI. And the second, so yes, thank you for that question. And the second is machine learning methods. Right now, they're using machine learning at the cloud level and some a little bit at the local level for local and monitoring the system. But we are very close to having auto tuning, and we are about to implement machine learning at the local level to control the unit.
Oh, it's fantastic. Good deal. Thank you for addressing those, Pete. All right. Next one is for Jessica, if you don't mind. Jessica, so in the approach that you guys took at Rubberlite, could you give us some insight as to how this new technology architecture has helped your team become more proactive?
Sure. So this new architecture has primed us to become more sophisticated in the way we operate. We started looking at only the one monitor with 30 or so changing values during our production runs. And sometimes it's hard to see what is truly going on with the process over time with just one flashing number, let alone 30 of them. So this project enabled us to transition most of our data points into real-time trend lines that are displayed on 3 monitors. And this gives us a better picture of the process and what it's doing and allows us to correlate several data points simultaneously in real time. Now, this practice has allowed us to become more proactive on several occasions. For example, one time we were able to tell that a pump was near failing by correlating its speed and its outlet pressure with the flow rate of the chemical that we were seeing. And so after the run, we investigated and we fixed the problem instead of letting it get worse and experience unplanned downtime or having this issue to affect product quality in a negative fashion.
Okay, cool. And we had another quick one just come in, if you have time for one more. This is from Eric. He said, for Jessica, he said, why was there not a business case to upgrade the XP computer before?
Well, the quick answer is that there was. It's just that as technology sort of progressed and got more and more sophisticated, we decided to just go ahead and do like a managed application using Aviva system platform, formerly Wonderware. That had been in the works for several times, but I guess resource constraints would be another quick answer because Rubberlite at the time did not have those that expertise on hand that was me, I guess. I was a contractor at the time. So it was always sort of in the plan. It's just how we were going to go about it is what changed. And that's how we came upon a Stratus.
That's great. Thank you very much for addressing that, Jessica. And just looking at the time, I think we have time for one more, and we'll get this one to Craig. Craig, if you don't mind, could you help us understand what should leadership be thinking about when approaching the IT OT convergence? You know, with what we've heard from our panelists today, leaders that are listening to this or leaders that are viewing this, what should they be thinking about when approaching this convergence?
I think you need to take a culture approach and not just a technology approach. I think the technology exists. I think the problem is that it's not going to get anywhere unless you can play the role of having the people from both the IT side and the OT side want to adopt it. I think you have to be able to establish kind of the what's in it for them mentality, which is, okay, by going through this whole process, why are you going to enhance their quality of life, enhance their job performance, and not look at it as something that possibly could cause the elimination of one or other departments or people. I think that you really have to take the cultural side. We find sometimes is the culture eats technology, shall we say. So I think it's really important that they recognize they need to sit down with these people, explain what's in it for them, and also to really collect their input. You know, it's not like just, this is what you're going to do. It's like, here is what we're thinking about. Here's our vision and here are our goals, and get good suggestions and input so you can make it work. So they feel as though they have an ownership and they are embracing the challenge rather than looking at it as something that's you know, going to work possibly against them, either for their job functions or their careers looking forward.
Oh, that's great feedback. Thank you very much, Craig. And like I said, I think that's all the time we have today. That would be the last question that we address. So first and foremost, I want to thank our panelists again, Jessica Spurlock, Peter Fotos, and Craig Resnick. And also want to thank all the participants in our workshop today. We appreciate you dialing in and listening to our concepts that we have here today. So without further ado, thank you all, and have a great rest of the day.
Thank you. Thank you for attending.
Thank you.